Objectives in this session are to know the location of the lateral ventricle, where it lies in the cerebrum, various parts of lateral ventricle, and the relationship of each of these parts, and the extensions of the lateral ventricle, and the applied anatomy. So let us look at this picture, which you can see on your screen at the moment. Do you find anything unusual here? I think very prominently you can see a middle horn, which is not usual. So that is how we have an animal with the 3 horns. So that is a bit unusual to be seen. So let's talk about something usual which we have, that is the lateral ventricle. So lateral ventricle also has 3 horns and a body. So these are the parts. So which is these are the 2 pictures of the cerebral hemispheres. I've taken this picture from Gray's Anatomy, in which we can see that the picture which is there on the right side, it shows to you the outline, or you can say this is the surface anatomy of the lateral ventricle. So this is what we are viewing from the right side or the left side, this being the frontal pole and this being the occipital pole. So we have, this is what is called as the anterior horn, which is projecting into the frontal lobe of the cerebrum, and we have a part which is called as the body, and another extension which is going backwards towards the occipital lobe, which is what we call as the more likely, which should be calling it the posterior horn. And then we have a part which goes a little behind and then goes front and then laterally and anteriorly, and that is what should be called as it is also called as the inferior horn. So these are the 3 extensions: anterior horn, which is bigger, posterior horn, and the inferiorly is the inferior horn. So in this picture, which is a view of these 2 cerebral hemispheres from behind or in front from front. So what you see, these are the 2 anterior horns of the lateral ventricle, this being the projecting part, which is the posterior horn, which of course will be projecting backwards, which you can't appreciate in this diagram. So this is how we have the anterior horn anteriorly projecting a body, and its extension backwards would be the posterior horn, which will be this one, and inferior extension, which is called as the inferior horn, which you can appreciate in this diagram. So that is how we have this cavity, which is called as the lateral ventricle. So these are the parts of the lateral ventricle. So we'll be talking about each of these lateral ventricle, parts of these lateral ventricle, which is anterior horn, body, posterior horn, and the inferior horn. And you can see a few more cavities here. One is this, which we have already done, that is the 3rd ventricle, and the cavity here, the 4th ventricle. And a bit about what we are talking about, that see this diagram, which takes you back to what we call as the neural tube. I wanted to talk to you about this diagram because of the reason that I want you to understand how these cavities are connected with each other. See, taking up this diagram is about the neural tube, and this part being the part of the forebrain or the prosencephalon, which is further subdivided into telencephalon and the diencephalon. And then we have the next part, that is the mesencephalon, and the hindbrain part, that is the rhombencephalon, which is further divided into metencephalon and the myelencephalon, which will form the medulla and the spinal cord. So the lumen of this tube is going to get dilated a few places. It got dilated a few places, and the telencephalonic part, because it divides and forms 2 enlargement called as 2 cerebral hemispheres. So the lumen also get divided into 2, and that is how the 2 lateral ventricles are formed. And then, of course, we have the cavity of the diencephalon, that is the 3rd ventricle, and the cavity of the midbrain, that is the aqueduct, and the cavity of the hindbrain, that is the fourth ventricle. So that is why all these cavities, they have to be in continuation or in communication with each other, because it is the same lumen of the same tube. And also here you can find the two lateral ventricles will also be connected with each other, which we call as the interventricular foramen. So this is how we have the development part. And this again the same diagram which we referred to before, that is the antihorn, body, posterior horn, inferior horn, and this is the diencephalonic cavity, the third ventricle. So that is how the ventricles have come into place today. Right, so about, see, these are the brains which you have left behind in the dissection hall. We've been playing with them for some time when you're not there. So when you come back, you will see them like this. So this is from which table? I don't know. Any table can identify their brains? Anyhow, they all look the same, but the differences. Okay. So this is the medial surface of the right cerebral hemisphere, this being the frontal pole and occipital pole, and the prominent feature of this surface is this structure which is called as corpus callosum. And you know the parts, can you quickly revise the parts of the corpus callosum? This is the rostrum, genu, this being the body, and the thicker part behind is the splenium. Okay. Okay, then this is the other half of the same cerebral hemisphere, and you can again identify this prominent structure, that is the corpus callosum. And you can see a very thin sheet of membrane. That is what is called as the septum pellucidum, which is going to separate the two ventricles. Okay. Okay, this is what your cavity we'll be talking about. This cavity becomes visible. That is the cavity of the lateral ventricle becomes visible once you cut the corpus callosum in the midline. So on either side of the septum pellucidum, so the septum pellucidum has come on the left side in this section. So what you see is the body of the lateral ventricle in this picture. And the anterior horn of the lateral ventricle will be projecting here through this into the frontal lobe, and the posterior horn will be projecting from through this opening and will be going backwards towards the occipital lobe. And what you will find is that the inferior horn will be coming down like this. So that is how we have the three horns as the extension of the body being this part. So let's try to understand the anatomy of each of these parts. So this is another view, another picture. The corpus callosum. Can you identify this big structure here? This is this is one cavity. This is prominent structure. Anybody identify? It's been a long time you have seen this. Yeah, if you could identify it as thalamus, that is wrong. But if you identify it as the caudate nucleus, that is absolutely right. All right, so so that is the caudate nucleus. If you remember, caudate nucleus is the head, body, and the tail, which will be, and this is the thalamus and the hypothalamic sulcus, so hypothalamus. So this is the thalamus, this is the caudate nucleus. So caudate nucleus is the head, which is projecting forwards, body, and the tail, which is going to be winding. And you can see something over here, that is the choroid plexus projecting from below. Okay. Right, so let's move ahead. Now this is the diagram, a picture of, we had made an incision section at this part of the corpus callosum, closer to the genu part of the cerebral hemisphere. And once we made that incision, after that it looked something like this, in which this being the medial surface and this being the superlateral surface, and this is the part of the temporal lobe here. So this will be the sulcus, prominent sulcus here, that is the posterior ramus of the lateral sulcus. Okay. Right. So now, if this being the medial surface, you can see this is the corpus callosum. So you can see two sections of corpus callosum here, one here and one here. This will be the part which is the part called the rostrum. So you can see two parts of corpus callosum. This is a coronal section to make you understand about the anatomy of the anterior horn of the lateral ventricle. Now, if you see this being the anterior horn, this being the right cerebral hemisphere, so this being the medial surface, this being the lateral surface, the one big bulge which you see over here is this bulge, which is the head of the caudate nucleus. So head of the caudate nucleus is going to form the lateral boundary plus the inferior boundary, infralateral boundary of the anterior horn of the lateral sulcus, while the above you can see this is, what is this? This is the corpus callosum, which is coming here, which is going to be forming. So it lies primarily in the which lobe of the cerebrum? The frontal lobe. So frontal lobe of the cerebrum. So the thalamus, the head of the caudate nucleus is going to form the lateral wall as well as medially, it will be going to form the lateral wall, right? Okay. So now, so that is about the anterior horn. Now let's try to understand the body. Now, body of the lateral ventricle, which is this part. So this was an anterior horn. This is the body. Now, in the body, what we find is that we have the this big set of fibers, which is called as the corpus callosum. So body of the corpus callosum, body of the lateral ventricle principally lies within the this big hemisphere, that is the parietal lobe and the frontal lobe, the posterior part of the frontal lobe, that is, and the parietal lobe. So these are the two hemispheres which are housing the body of the lateral ventricle. And the cavity of the lateral ventricle is separated from each other by this. So this is the body. And what you see here, because you can see another big swelling here. So this is a section. Can you identify this section? This is a coronal section, but almost at this place, because you can see this huge bulge over here, and this huge bulge can be which bulge? What is this? What is this? See, this cannot be anything but the thalamus, and the cavity medial to the thalamus has to be the third ventricle, right? So the ventricle number 1, ventricle number 2, which is 1, which is 2, we don't know, but we have two lateral ventricles, so the cavity next will be called as the third ventricle, of course. So you can call right one as first. I mean, you can have a choice of calling each one, whichever, as first. Right. So coming to the boundaries or relationship of the body of the lateral ventricle. So we have in the roof, we have this part of the corpus callosum, and the septum is this partition between the two lateral ventricles, which is going to form the medial border of each of the ventricles. Bodies of each of the lateral ventricles is the septum, called as the septum pellucidum. At the inferior margin, you can find something over here. These are the columns of the fornix at the lower edge of this, which are the columns of the fornix over here, which will be here at the infromedial border of the body of the lateral ventricle. While the lateral boundary, we find another group of neurons over here, which is the caudate nucleus, which was here. See, the section is at this place. So you can see the caudate nucleus laterally. So this is where the caudate nucleus is. And over here, we will find the thalamostriate vein. So over here, we have this, what is called as a superior thalamostriate vein, along with the stria medullaris. So quite the caudate nucleus, the thalamostriate vein, and the stria medullaris. So these are the structures which will be lying in the lateral wall of the body of the caudate, body of the lateral ventricle. So that is about the section of the body of the lateral ventricle. Now this is again a repetition of the same diagram. Picture which you see, this is the caudate nucleus, the thalamus, the septum pellucidum. At the inferior part, we have the body and the column of the fornix, which will be more posteriorly located. And then we have the body, and this is what you find, which you see in the previous picture as well. This is where the choroid fissure is. The choroid plexus will be, I can see them here very clearly, projecting from this edge between the fornix, okay, through the, medial lateral to the fornix. All right, so now this is another picture of to show you the roof of the lateral ventricle. So you can see this is the corpus callosum fibers. So this form the roof, the body and the splenium part of the corpus callosum forming the roof of the lateral ventricle. Right, so we can move ahead and move on to talk about, there's another picture, same. Okay, to talk about, so we have talked about the anterior horn, the body, and we are now talking about the posterior recess of the lateral ventricle, which is called as the posterior horn. So this diagram, this picture in which what you see, this is the anterior pole or the frontal lobe here. This is the occipital pole behind. And what you see is this recess, posteriorly directed. And that is what is called as the posterior horn. You can see it is projecting into the posterior lobe or the occipital lobe. So this is the posterior horn of the lateral ventricle. So which you can see in this section, coronal section also. You can see the choroid plexus also in this. So this is the right cerebral hemisphere, this is the left cerebral hemisphere. Now, before we see this picture, I want you to quickly revise some parts of the corpus callosum. So in this diagram, what we see, this is a corpus callosum. As you know, corpus callosum forms a set of fibers. Which set of white fibers? The commissural fibers or association fibers or projection fibers? Which one of these? Association or projection or commissural? So they are commissural fibers which connect similar areas on the two sides. Okay. So as you can see, this is the part which is from the starting from the genu part. So this is the what is called as the two connecting the two frontal lobes. That is the fossa minor. This is a part which is the from the body of the corpus callosum, and this part from the posteriormost part of the corpus callosum, that is the splenium part. What we find in some set of fibers, they're going like this, and some set of fibers are like this. So going to the occipital lobe only, but few fibers are separated. So this is what is the purple color thing is the posterior horn of the lateral ventricle, which you just saw. So some fibers from this go medial to this, and some fibers they go lateral to this. The one going laterally, they are called tapetum, and the one going medially are the forceps major fibers. Forceps major fibers. So forceps major fiber, you can understand, will be seen in which. So if this is the posterior horn, so where will both these set of fibers arising, part of which are part of the corpus callosum, how they are going to be related to the posterior horn of the lateral ventricle? One will be median, another will be lateral. And there's lateral, further lateral to this fibers called tapetum. We have another fibers which have to finally reach the occipital lobe, number 17, 18, 19. That is the optic radiations. Optic radiations. Okay. So therefore this forceps major fibers will be lying medial to it, and forceps major minor will, tapetum will be lateral to it. All right, let's go back to this picture again. Now in this section, what you see, these are the coronal section. What you find here, again, this is that same right cerebral hemisphere. What we did in this is that we cut it at the posteriormost part of the corpus callosum, right? And to show you the posterior horn or the posterior recess of the lateral ventricle, this both are the same, the two surfaces of the cut part of this being the posterior half, this being the anterior half. So what you see, both, what you see, this is the medial surface, right side pyramid. This is the lateral surface, and this you can see the choroid plexus. After that, we remove the choroid plexus, but to show you the rest of it, which you can see in the further diagram, which is this. Okay, right. Right. So this is that section. So we have enlarged it also to make you understand. Now look at this in the enlarged view here. I think all you are oriented to this diagram, this picture. This is the right side of hemisphere, coronal section, this being medial surface, lateral surface, and we are watching from behind. This is medial. We are watching from behind. So you can see this recess, which is the recess of the posterior, which is called as a posterior horn of lateral ventricle. Posterior horn of lateral ventricle. Okay. Now here you can see a huge, this is the same enlarged view. This is a huge bulge. And just now we saw some fibers which are going to be medial, which is the, remember that, see, this is the posterior horn, medial. This is the forceps major fibers, which raise a bulge on the medial wall of the posterior horn. That is what is called as that obviously it's like a bulge. It's like a bulge. We call it a bulb. We call it bulb of the posterior horn of the lateral ventricle. And if you remember, there was a sulcus here which was projecting in the medial surface of the occipital lobe. That is the calcarine sulcus. So this calcarine sulcus projects into the posterior horn. Below, of course, below it is below the forceps major fibers, below the, which is called the bulb of the posterior horn. So, and this elevation produced because of this indentation of the calcarine sulcus is called as the calcar avis. It's called calcar avis. Right. So coming to the, so this is the posterior horn. So this is the right posterior horn. So and further laterally, if you see, we had talked about two set of fibers. Remember, one was this. What is this called? This will be called the fibers called from the corpus callosum. No? Remember, this is the forceps major. This is the fibers which are coming backwards, right? Backwards. So that is the tapetum fibers. And further laterally, we will have the optic radiations which are coming. Okay, so that is how we have the relationship of the posterior of the lateral ventricle bulb, calcar avis medially, the optic radiations, and the tapetum, right? Okay, now this is the diagram which you sometimes get to draw in your exams. So you should, you can, this is a schematic diagram which again the same posterior horn of the lateral ventricle. Again, this is a posterior horn of the lateral ventricle seen from behind, right posterior horn of the lateral ventricle seen from behind. You can easily see this, the bulb of the, formed by the bulb, formed by the forceps major fibers, the calcar avis over here, the tapetum and optic radiations, right? Okay, so that is about the posterior horn. Okay, so this is how we had the body, and then we had the posterior horn, and we are trying to get into the other horn, that is the inferior horn. So we had started from the anterior horn, we went to the body, went directly behind to the posterior horn, and then we're trying to get into the inferior horn, which is actually infrolateral. Okay. So let us try to see this. All right. Now this diagram, let's see, this is what we did. This is the medial surface of that cut section of the right cerebral hemisphere. This is the anterior, and now I mean, you got to believe me, this is anterior and this is posterior. And somewhere here you can identify, if you can identify, this is the corpus callosum. And so knife went through over here, it did this to this section. Is this surface. Now this is the coronal surface, this is the medial surface now. Sorry. This is the medial surface. Sorry, this is the medial surface, and this is that coronal surface or anterior surface now. So what you can see is a corpus callosum here, which is over here. Right. So we were made to talk about. So this will be the, because if this is the corpus callosum, this has to be the body of the lateral ventricle. So projecting backwards would have been the posterior horn, and from there down, coming down here is the inferior horn of the lateral ventricle. Same, this is the same picture, but little more tilted medially. This being the medial surface, this being the supralateral surface. So this horn, exactly seen from front, looks like this. So when you see this, what we see, now some part of the brain is lost over here. You don't see most of the temporal lobe, which is lost. So, but if it was there, you could have appreciated there's a sulcus here, which is projecting medially, that is called as a collateral sulcus over here. This is medial, it's a little lateral over here, collateral sulcus. So collateral sulcus would have been here. And this is the cavity which we are talking about, that is the inferior horn of the lateral ventricle. This is the cavity of the inferior horn of the lateral ventricle, which is seen over here, and which, to begin with, from the body, it starts backwards, and then it starts backwards, and then comes forwards and laterally. So that is how it curves down to be indenting into, invaginating into the temporal lobe. So what you see in the floor is very interesting. What you see, which we had done in the Saturday class also. You have seen it before. What is it? It is the hippocampus, and you can see this hippocampus here. And so this eminence, which is formed here in the floor of the cavity of the lateral ventricle, is what is called as the collateral eminence, because this is formed because of the collateral sulcus is called collateral eminence. And lateral to this is this over here. What is it called as the hippocampus, hippocampus. And projecting medially is the choroid plexus, which you can appreciate in this diagram also. This diagram. Can you appreciate? Can you go compare this section with this diagram? Can you or can you not? I have purposefully obliterated this part for a reason. So this is the inferior horn, and this is also inferior horn. What you see in blue is the inferior horn. Do they look the same or they're different? See, they almost look the same. They are mirror images of each other, because one is on the right side, another is on the left side. One which you see, this is the right side, this is the left side pictures. You can see from here as well. This we are watching from front. So that is why the choroid plexus are here, no? The choroid plexus are here on this side, they are on this side. Okay. So that is how the collateral eminence will come over here, and this is where we have the hippocampus. So that is going to form the floor of the lateral ventricle, inferior horn of the lateral ventricle. And as you can see, this is the thalamus. So we have the caudate nucleus here in the body, and it is winding around the thalamus. So it is becoming the roof of the inferior horn of the lateral ventricle. So that is how it goes. The inferior horn of the lateral ventricle will have the roof. In the roof, we'll have the tail of the caudate, the thalamus striate vein, and the stria ventralis. And we in the floor we have the hippocampus. Medially we have the choroid plexus. Laterally we have this eminence called as the collateral eminence, because of the indentation of the collateral sulcus. So that is so this is of the left side seen from front. This is the right, which you can see in the section from front again, but of the right side of the hemisphere. Okay, now so now let's quickly revise this what we've done. So we talked about the lateral ventricle, which is a ventricular cavity containing the CSF. So it has a body, anterior horn, a posterior horn, which are the occipital horn, the inferior horn, because it goes into the temporal lobe, we call it the temporal horn. And we have two lateral ventricles, one in each cerebral hemisphere. So they are connected with each other through the interventricular foramen. And then we have a connecting channel which connects it to the third ventricle, and then which goes to the aqueduct into the fourth ventricle. So that is how most of it goes into the subarachnoid space, so that three foramina, one in the midline, two laterally. So, and rest goes into the central canal. Right. So now, now once you know the anatomy of this region, I wanted to share with you some applied anatomy part of the lateral ventricle. See, this is a picture of an 80-year-old man who had a tumor of the right ventricle. First of all, let's appreciate what these MRI scans are showing. These MRI scans, one is the axial scan on the left side, one on the right is the coronal section. So you can easily appreciate this is axial scan. So in axial scans, this is right and this is left. So as if you're watching it from below. The person is lying down and we're watching it from below. So you can see something not right over here. So this, there would have been a corpus callosum, and this is not right. So this is that right ventricular cavity, and the left ventricular cavity has been this something, a mass which is pushing it to the left side. So what can go, I mean, what abnormal anatomy can happen in relation to the lateral ventricle? See, as we talked about in the previous diagram, see, because it is a cavity which is filled with the fluid, so what can happen is there's something outside the lumen, which we call it, we can have an extraluminar compression of this cavity, as we saw in this MRI scan, or we can have a blockage in the pathway, the intraluminal factors, which can cause the previous cavity to enlarge. So suppose we have an obstruction here, the lateral ventricles will enlarge. If you have an obstruction here, the third and the lateral ventricle enlarge. If we have an obstruction here, so obstruction here, or fourth ventricle and the third ventricle, all ventricles will enlarge. So depending on where the uh, blockade is, the previous cavity will get enlarged. So that is how we will have intraluminal factors causing, which can be increased production of CSF or a blockage, or a decreased absorption in the choroid plexus. So that can cause changes in the cavities. So I like to show to you a picture, a video, which let's see if it plays. Let's see, please. Okay, this, let me first make you understand what this picture is about. So this picture is about, video is about, this is that same person whose MRI you saw, in which, because if you remember the that mass which was there, which was, where was it? That was, if you're forgetting, I can open it again. That was in the right side, right side. In the coronal section also, you can see the right cavity. So this, the picture which you just saw, starting to see this, they have tried to approach this mass over from this place. So let's see it. This will take another 2 minutes. That'll be the end of the story for lateral ventricle. So what you see, we are watching it from behind now. This is the coronal suture, and somewhere here will be the sagittal suture. We're in the, this is the frontal bone, this is the parietal bone. So this, what you expect to see, this being frontal pole, so the frontal bone, so this is the anterior, and we are behind, we are watching behind and above. So what you can see here is what he's holding with his forceps. Can you see this? This is the thick covering, which is the, what thick covering? That is the, this is the dura mater, and underneath that you can see the blood vessels, so the arachnoid and the pia mater. Here below that, deep to that, we see the cerebral hemisphere. So this has to be the right cerebral hemisphere. So I'm playing this video. Let's see. So and what you see here is the right superior sagittal, the superior sagittal sinus over here. Okay. So what they do is, okay, so they're trying to approach it. The interhemispheric suture, that is the longitudinal suture between the two cerebral hemispheres. So what they're doing, you can see there's some whitish thing over here. So that will be the corpus callosum. This is the corpus callosum. This is the right cerebral hemisphere. This is the corpus callosum seen from above. So what should be lying below this? This is the corpus callosum. What should be lying below this? You can see this is the corpus callosum. So What you like below this is the body of the lateral ventricle. And you can see the parietal blood vessels which have been retracted. So what they're going to do, they make a little opening in the roof of the lateral ventricle, that is through the corpus callosum. So they're going to make an opening in the corpus callosum because through the roof there is the least chance of any injury to the brain. So they're going to go. So there, now you can see this is the opening into the lateral ventricle. You can see the CSF of the lateral ventricle coming out. So through this corpus callosum, they're trying to reach that mass which was there, which we saw in the MRI scan, was there in the right lateral ventricle body, which you should be able to see it as soon as you can see that mass appearing. They're going to open it. Yeah, now they've enlarged that opening in the corpus callosum, and you can see that mass which is somewhere over here. So retracting here, the mass, so you can see this. So retracting it. So mass has been identified, which you can see very clearly. It has the MRI scan lying in the. So somewhere here, in fact, this septum president here will be the septum separating this lateral cavity, ventricle cavity body with the other side of left lateral ventricle cavity. So there will be. So let's move ahead. So they finally we have removed that mass from adhesions, all these adhesions which were trying when they finally all the connections we had. So they should be able to take it out. So you can see it being delivered out. It was a huge tumor. All right, so wonderful. So about this video which we had to show you. So that is about, if you go back to so that was about the lateral ventricle. So I hope you enjoyed this session, and let's see how it goes. And you've been liking the other videos also sent by other faculty members. So all in the department are not resting because you're away. We are all working for you. So don't worry when you go back, and when you are away from us also, we are always thinking and working for you, thinking about you, so that material you don't lose any academic activity. So academic activity has to continue. It can't stop. But you also please take care and continue studying, and please be connected to us through your CRs, so that we also keep updating about you in time. So thank you very much. So we are going to close this session and see you in the next session. Thank you.